Hypothesis testing the basic steps and components that we need to use, and we'll use it, you can say, all the time during the course. So it's once you have got this, you will use it throughout the course. Okay. So yeah. So the point is that what we say, as you know from last time now, we want to define a hypothesis, and then we want to find out whether, given that we have observed this data, can we then conclude that we find what we say is a significant effect. And the point is, well, as you saw in the example, the point is, we'll say, if we can reject the null hypothesis, that there's no difference between the two samples, the mean of the two samples, then we can say that we found a significant effect if we can reject that null hypothesis, because then we conclude that they are different. So it's the same, and what we will need to do is calculate a p-value, and then we will compare that with the significance level alpha, and as standard we use alpha equal 5%. But as you also saw last time, it's a matter of the risk you want to take of making a mistake, you can say. So a lower significance level, then you'll be more sure that you actually found an effect, if you can conclude that. Okay, and then, so the steps in doing a hypothesis test is, first, formulate the hypothesis. Actually, we should do that even before we do the experiment, and before we say what we want to find out, we need to say in advance what we want to find out. So we formulate this hypothesis and choose our significance level. So we set the level of if we set that low, then we're more sure that we have found an effect. We will be wrong less times from the significance level. Okay, in some way, you can say. Then we want to calculate using the data the value of the test statistic, which, since we do hypothesis of the mean, then we use the t-distribution. So we will calculate an observed t-value in this case. But it could be in different settings another value, which we will also do later. But we call it the test statistic. And then we calculate the p-value and compare that with the significance value and make a conclusion. And alternatively, you could do that with the critical values or confidence interval, as we will see. And so what with the p-value, what if you want one when you blah blah blah. If you want to sort of phrase it in words, if you want to write a report or something, and you do a hypothesis test and you calculate the p-value, then this table 3.1 can give you sort of a way to phrase your results. So what we say is that if we have a very, very low p-value, then there's very little chance that the null hypothesis is true. And then we say we have very strong evidence against the null hypothesis. And then it increases, and the formulation sort of increase until we have over 0.1. We say we have little or no evidence against the null hypothesis. So it's just a way to help you phrasing these results in words, you can say. And now the p-value. That is maybe the most, I think that once you kind of get that, then it becomes rather obvious what you do. Now I hope we can film this, but now I'll just try on the blackboard to illustrate, the p-value, because I think it's kind of important. And the point is that we use the phrasing under H0, under the null hypothesis. That means given, so we write under H0. That means if the null hypothesis was true, then what would happen would be that then the world would look like this. Around 0, there is a distribution, which we call the T distribution. And it has degrees of freedom n-1, the number of observations. So if the null hypothesis is true, so what we state is that if the world is as we state in the null hypothesis, in this case that the two means are really equal, then our test statistic, which we will get to in a point, follows a T distribution. And then the p-value is, let's say that we say the world is like this. Then we say, okay, the p-value, let's say that we observe this t-value. And then we say, okay, the p-value, that is defined as, you can read it up there, the probability of observing this value under the null hypothesis. So if the null hypothesis is true, then the probability of observing this one or something more extreme, it's this area, and that's what we call the p-value. If we have a double-sided, so if H0 is, for example, now I just say mu is equal to 0, and then the alternative is, then you know that the alternative is the negation of this expression, is that mu is different from 0. If that is the case, then we say more extreme means also on the other side. So in that case, we will include also this area, this probability mass, since we say that it could be either side of, since the alternative is both sides, then we include this one. So therefore we calculate the p-value in that case as 2 times the probability of observing this T statistic, and that is calculated in different ways then. But observing this being greater than the observed value. So the probability of being further out, and since we need also this value and the distribution is symmetric, we can just multiply this with 2. So, and the point is, now it's really easy to see somehow, if you think about it, that if this was really the case, then at alpha, at the significance level, if that was the case, and now since we have it in both ways, we take half of it. So let's say that alpha half is this area out here. So that's 2.5%. Let's say that we have that. Then we can see that if this is true, sometimes we will be out here. It's totally, sometimes we will just be out here when this one is true, when the null hypothesis is true, and we will make the mistake alpha times, since the probability of getting over this value or over this value will be the level of alpha, which is usually 0.5%. That's why I wrote the 2.5%. Okay, but that's the point. So we can see that if H0, if it is true, we make, just by random chance, we make the mistake of rejecting it falsely in the level of alpha. So if we say alpha is 5%, 5% of the time we will wrongly reject H0 because we will naturally just get a value out here. So that's how it functions. I hope that works a little bit, helps a little bit, this little explanation. So then we come to the two-sample